In fact, the order is not important at all, but I usually do the chain rule last. Well, we'll see about that, won't we, KJ? Okay. I better plug this in now.
Do you teach half math too?
Sometimes I do. Sometimes I don't. Technically, everybody here did half maths because half maths is just semester 1 maths. It's the same thing. The only difference is it's a smaller class.
But then, if they're studying semester 2, they're like studying semester 1 again.
Yes.
Exactly.
Yes. So it's almost like they repeat semester 1. What's wrong with you?
No, what about them semester 2 maths? They're not doing
They don't do it. They only do half of it. Hence the name.
But semester
Half maths.
No, then this won't be like 10%?
It'll be worth a 50% module, half the credits. Half the credits for UK applications. So. Right, chain rule now. Do you mind getting the... no, you can leave the light on. You can still see, can't you? Yep. Okay, so chain rule. So have a look at this type of problem. Yep. So, kind of looks like the product rule, but it's not really the product rule because the product rule would be if they were multiplied, but it's not. What's actually happening here?
It's powers rule.
Yeah, it's the x goes in the sign, goes in the e.
What?
Say what? I'll show it again. X goes in the sign, and the result goes in the e. Yeah, you're still with me now. Yeah. So it's not the product, it's not the quotient, it's what's called the chain rule, where you have this idea that there's something on the outside, which is like e, and there's something on the inside, which is sine. I'll give you another example. For example, if you had square root sine x, there's definitely an inside part, that is sine x, and the outside part, that is the square root function. Here's another example. 2x plus 1 power 10. There is the inside function. And what's the outside function?
10.
Power in 10. Let's do something like this, finally. Sine x squared plus 1. What's the inside function? The quadratic x squared plus 1. And the outside function? Sine x. So these are the types of problems you deal with when you're dealing with chain rule. Okay? So the chain rule, the formula, so to speak, is dy dx equals dy du dx. Now this makes sense because in a way the du's cancel, leaving you with dy dx. And usually we can choose the u. It's our choice. And we usually choose the u to equal whatever's on the inside. Okay. The proof, we could do the proof, but I'm kind of happy enough just to say, although I'm not really supposed to, but I'm happy enough just to say they cancel. It leaves you with dy dx.
We can choose you any...
Yeah, but it's only useful if it makes it equal to the inside part. Let me show you. Can I go down? So suppose we have y equals, let's say, sine x squared plus 1. We choose... So let u equal x squared plus 1. By the way, if u equals x squared plus 1, what does du dx equal? 2x. That is true, isn't it?
Yeah.
Okay, now I'll put that back in, and we get y equals sine u, because that's u, the inside part. True? So, if y equals sine u, what's dy du? It'll be cos u. So now let's use the formula. Dy dx equals dy du, du dx. Now what's dy du? dy du is what? We have that result already. Cos u. And what's du dx? 2x. Now, u is something we chose, so we should write it back in terms of x. What does u equal?
X squared plus 1.
So this is the answer. This is the derivative of sine of x squared plus 1. I'll do another one, and then I'll show you a quick way you can do it.
We can
I can go straight onto it?
no, we can write it. Right?
You need to write this down. Yeah, go ahead. We're just waiting for Fahad.
Nobody's writing or
Everybody has it, I think, Fahad.
okay, then I
I go?
Yep.
Right, I'll give you... Do you want to try one, or do you want to see another one? See another one? So, we'll do one with, I don't know, like a power. So, let's say 3x plus 1 power 10. Okay, so step 1, let u equal to what? What do you think? Inside part. 3x plus 1, good. So what is du dx, the derivative of u?
3.
Now, if u is equal to 3x plus 1, then that means y is equal to u power 10. Yeah, seems believable.
Yeah.
So what is the derivative of y? dy du? 10u 9. So, by using the chain rule formula, dy dx equals dy du, du dx. What is dy du? It's 10u 9. And what's du dx? du dx is 3. So this is 30 u 9. But we shouldn't write our answer using u. So what does u equal? 3x plus 1 power 9.
So can you tell me why it's 9? 10 u equal 9.
Ah, correct. U power 10, derivative, bring the power down.
Oh, sorry.
Okay. So I'll give you one like this to try.
Yep.
Yeah? Okay. Write this down for me. Y equals log sine x, we'll say.
No, it's not.
Yeah? You got that? I need to close the screen for a second. Do you have that? Yeah? Yes? Okay.
Log sine x?
Log sine x.
So what is this thing inside then?
What's the inside part, do you think?
Sine x?
Correct. So continue. I believe in you. Don't let KJ be the first one to finish. Just because he has a new maths book. You have it finished, Fahad?
Yep.
Oh, look, there's my density video. So this is, I'm uploading equations of motion lesson. Okay. Everybody's finished now? Karar?
Yeah,
You don't sound too confident.
not really.
What answer did you get?
These are the options for you.
Huh? I'm just uploading putting up the new links for the videos. Okay, let's have a look. So, right. So u equals
Sin
sine x. So du dx
cos x.
cos x. So y equals log u. So what's the derivative here?
1 over u.
Very good. 1 over u. So dy dx.
Cos x into 1.
Yeah, let me just write the formula out one more time. dy du dx. But basically, you get the idea here. It's this one multiply this one. Yep.
In exam, we don't have to write dy over u.
No, just be careful if you don't. Don't make a mistake.
So we can exactly write the answers in the one.
Yeah, but I'm saying if you don't, just be extra careful you don't make a mistake. So this will be 1 over u times cos x. But what's u?
Sin x.
Sin x. So this is cos x over sin x. You can simplify. Correct, it's cotan. Or if you want, that's 1 over sine over cos,
Or 1 over tan.
which is 1 over tan. Yeah? What's wrong? Everything cool?
1 is 1, okay.
Yeah, yeah. Okay. Now let me see how you do with this one. Well, you know what? Before I give you another one, let me show you the quicker way to do it. So, I'll do it with a little bit of color coding. So let's say we have sine of, we'll go with good old x squared plus 1. Because I think we did this one, didn't we? It was 2x,
No, no,
2x cos x squared plus 1. Now the quick way of doing this is you differentiate the outside function. So the sine function, what's the derivative of a sine function? Cos. So this becomes cos, and the x is like x squared plus 1. Then, after you differentiate the outside, you multiply by the derivative of the inside. So what's the derivative of the blue part? 2x. Okay. Let's try another one we did. What was the last one I gave you? It was y equals log
sin x.
sin x. Okay, so I'll color code it. In red is the outside, and in blue is the inside. So I differentiate the outside. What's the derivative of a log function?
1 over x.
1 over x. So here, instead of being 1 over x, it will be 1 over sin x, because that's like the x. And then what do I multiply by? Derivative of sin x, which here is cos x. So again, it's the same. Cos x over sin x. Yeah, well, if you want, but I mean, but this is the thing, look, this is the reason I record the lessons, because if you write this down, you miss everything I'm saying about the colours. You know, like if you just showed that to someone and you said, oh yeah, here's the question and here's how you get the answer. Well, how? You know, because this is why I think the recording is good, because you can hear how to do it. You can't see how to do it here. So let's do another one, okay? What else did I give you as an example that we did?
Y equals 3x plus 1. Power 10.
Power 10. Okay, so here, what is the outside function?
10.
Power 10. And the inside? 3x plus 1. So the rule is, We differentiate the outside. So a power 10 function, what does that become? It becomes 10 power 9. Because remember, this is like x. And then I multiply by
Differentiate.
derivative of the inside,
Yeah.
which is 3. So again, I get the answer, 3x plus 1 power 9. You want to try one? Try to do it this way?
Yeah.
Yeah? So I'll give you y equals, let's make it a little bit tricky for you. Square root sine x. Got that?
Yeah.
Square root sine x. Okay. Density of that. You have an answer, correct? Square root sine x. Waves. Yeah, we'll have to delete those old material ones before I put up the new ones. Okay, the materials density lesson won't be there until later in the week. Right. Close. Okay, so we have an answer here. Before I start, I'm going to change it into sine x all power a half. So the derivative of a power half function is half the x part minus a half. Multiply derivative of sine, which is cos.
Cos x. Yeah.
Oh, yeah. I'm faster than my computer. Alright, let's step up this difficulty. Got this? Alright, let's try, I want you to try this for me. E sine x times cos x. What rule do you need here? And? Yeah.
Project for that.
Correct.
I don't remember any the formula for it.
Didn't you just do it last night?
Yes, we.
Yeah. All right. Derivative here. Derivative of the first one, like this, and then second one. Yeah. Can I remove that? Yep. No. Yeah. Right. Product rule first. So first it's derivative of this. Agreed?
Yeah.
But what rule do we need here? Chain rule. So we need to differentiate the outside function first. What's the outside function? Outside function is e. So it'll be e sine x multiplied the derivative of the inside function, which is cos x. What's wrong?
Outside is sin x.
No.
It's on the power.
Outside is e. Sine is inside. Sine is inside the e.
If, for example, x squared.
X squared.
So 2 is outside.
Correct.
Then y is sin x.
Because this is e of sine. It's like this, e of sine. So this is the inside and e is the outside. It's a bit like if I wrote like this, Fahad, e sine x equals exponential function of sine x. So this is on the inside. Now you might say, well, how come the 2 is on the outside here? Well, that's because it's just a 2. This is the squaring function. It's like this. It's like the square of x. So the x is on the inside and the squaring is on the outside. It's squaring x. Think about how you might say it. You would say square the x. The x is the outside. Here it's exponential of the sine. You don't say sine of the exponential. Because what would sine of the exponential be? It'd be like this. You're checking to see that they're different numbers, and they are. So, Fahad, think about it as a sentence. Would you say sine of the exponential here? No, you would say exponential of the sine. And this clues you on what's the inside and the outside. So the outside here is the e. Inside is the sine. Okay. Right, so that's the derivative of this times cos x. And then what's next in the product rule? Plus this first part multiplied by derivative of the second part, which in this case, yes, KJ, is minus sin x. And if you like, you can take the e sin x out, leaving you with cos squared x minus sin x. Okay? Right, I'll give you another one. Let's say level 5000 difficulty. Yes? Right, try this for me. You think you're so great. We'll put a log x here. Just calm down, alright? I haven't done any other thing else. And then we'll put a square root cos x here times, that's right. Yeah, so actually I'll write the x part first. So x square root, we'll make it sin x actually. X square root sin. Alright, Mr. Tough Guy, differentiate this. So I'll give you a minute to try it. So what rule do you need here?
Quotient.
Yeah. Yeah. And okay. You need all three.
How do I need to change over?
Square root sin x.
Square root
Sin x. Square root of sin x. The chain rule. Yes. so great. Almost, yeah. Then maybe I'll almost give you full marks.
I'm fine with 99.
Okay. Tried it?
Yeah. You need to simplify the like. You don't need to simplify.
Well, first piece of business before we start is we'll change the sine x with the root into sine x with a power half.
Yeah.
That's the first piece of business. Okay, and let's continue.
Oh,
What?
I thought X root.
You mean like this?
Yeah. No. Like, it's cube root, you put X there.
X root? Wow. No. No. That would be difficult. Right, so here. So first we need which rule?
The
Quotient rule, which says, now I'll do it bit by bit. So it's the bottom squared, and then it's the bottom times derivative of the top. And I won't calculate that just yet, I'll just write it in. I'll put a little tick here to mean I have to calculate the derivative here. Minus the top times the derivative of the bottom. So I've not calculated the derivative yet. I've just put little ticks to show where it needs to go. Okay, that's okay, yeah? So one of these is easy and one of these is difficult. Which one's the easy one? Well, here. That's 1 over x. This one is a little bit tricky.
No, mine's exactly.
Huh? Mine's there? Yeah. So, let's calculate the piece at the back first. So this will be at the back 1 over x, won't it?
Yep.
And then here is the same, x sine x power a half. So we've completed the second half of the quotient rules numerator. Now we need to do this part here. So what rule do I need here? Product first. It's a product before it's a chain. So here will be log x, and now here I need the product rule. And the product rule is first derivative of x. So first derivative of x, I won't actually write it in just yet. So first derivative of x times sine power half x plus x, and then what's next? Sine power half x's derivative. Now one of these again is easy and one of these is difficult. What's the easy one? This one here is easy. Derivative of x is 1. This is the tricky part. So let's do the easy part first. X sine power half x minus brackets. Right, so this is 1. So that's just sine power a half x. And sorry, I should maybe put little brackets here. It's the derivative of just that part. Plus x, and now to finish, I'll do it in red here, I need the derivative of this piece. So what rule is that? Chain rule.
Yeah.
So if I have sine x power a half, that's what this is here. What's the outside part? Power a half.
Yeah.
So how do I differentiate power a half?
1 half.
A half x power minus a half, which in this case the x is sine x. And then I multiply it by the inside derivative. What's the derivative of sine? Cos x. So this is the derivative here.
Just go over here. It's, oh yeah.
Stop tweeting.
That's it. Oh,
Thinking about my ham sandwich. That was a good ham sandwich. Tweet. Alright, did you write this down? Not yet? Let me mark off the ones for you to try.
oh my god.
That this is your life now.
It's very good. This is a good question actually.
2 from each. You're not writing a lab report. It's just sitting at home on your shelf. I know it is.
I'm actually writing.
You're not. Right, number 1, you can do A, B, Y, Z. And number 2, you can do A, B, P, Q. Congratulations on your counting. It is 8. I don't have any prizes for you though. Sorry. Well, you know what? Actually, here you go. Here you go. I'll give you a little something, KJ. There you go, KJ. And I'll put a star around your name. I'll do that better for you. KJ. That's just for you. Good job.
We can solve Lx square with the chain rule, right?
Why would you use the chain rule for log x squared? I mean in this question or a different question?
In this question.
What do you mean? Log x squared chain rule. I don't need the derivative of log x squared, so. Okay, got this? Yeah. So you can try those questions for a few minutes, and then we'll finish. Okay, so either the quotient rule or the chain rule, try those for a few minutes. Let's see how much time we have. Yeah, 5 minutes, okay?
Done.
No, not yet. Let me know when you're finished, okay? Go back to full screen for you. Oh, goodness. Tired.
You have to go home.
And teach more.
We have not for 1 hour tomorrow.
Thank goodness.
Is it tutorial?
Thank goodness. This is the last class of the week?
No.
No. Last class of the week is the tutorial.
So maybe the last class is 2 hours.
Yeah, so the second half.
Last class is for 1 hour. It's on Friday.
Yeah, it's 1 hour on Friday.
Perfect, that's the tutorial.
Yeah, it would be nice. There's no extra math for this semester?
Don't know. Is it on your timetable?
There's no.
And no extra maths.
Stephen is full.
Mine completely overfull.
You don't have any free classes.
Well, I mean, my free time is preparing stuff, so there's not much time. Okay, try these for 5 minutes, please. Can I close this now for Hodge? Yeah.